Hello everyone, myself Hans. Today we are going to solve the problem from topic tangent and normal, and the question is based on equation of tangent. Question is given, find the equation of the tangent to the curve, and the curve is given by x is equal to a sin cube t and y is equal to a cos cube t. Let's solve the problem. Given curve is x is equal to a sin cube t, and the second curve is given by y is equal to a cos cube t, and further we have to find the equation of tangent. Equation of tangent is given by equation of tangent is given by y minus of y1 is equal to dy upon dx, and this is x minus of x1, and we can also write this is y minus of y1 is equal to, here m represent dy upon dx, x minus of x1, and further we have to calculate dy by dx from the given curve. First, x is equal to sin cube t, differentiating with respect to t, we get here dx upon dt, and differentiating a is constant and sin cube t differentiating with respect to t, this gives 3 sin square t, and again sin t differentiating with respect to t, this gives cos t, and further we can also y is equal to a cos cube t differentiating with respect to t, this gives dy upon dt is equal to a is taking constant and cos cube t differentiating with respect to t, this gives 3 cos square t, and again cos t differentiating with respect to t, this gives minus of sin t, and we have to calculate dy upon dx. So we have to use here dy upon dx is given by dy upon dt into dt upon dx, and put the value of dy upon dt here. This is given by minus of 3a sin t into cos square t upon, and into dt upon dx is given by here dx upon dt. So we have to write here dt upon dx 1 upon of 3a cos t and sin square t, and from here 3a to 3a is cancelled out, and cos t to cos t is cancelled out, and sin t to sin t is cancelled out. The remaining is here is cos t, and the denominator we have to get here sin t. So we have to get here dy upon dx, which is equal to m is minus of cos t upon sin t, and further we have to find equation of tangent. So we have to let x1 is equal to a sin cube t and y1 is equal to a cos cube t, and putting in the equation of tangent the given value, we get here this is y minus y1 is here a cos cube t is equal to m, we have to calculate it, which is equal to dy by dx. This is minus of cos t upon sin t, and here x minus of x1, we have to let here x1 is a sin cube t, and further we have to simplify, we get the required result. We have to solving here, we get multiplying sin t with this cross multiplication, we get here y sin t, and minus of a cos cube t into sin t is equal to, here minus of cos t multiplying with this is minus of x cos t, and plus of a sine cube t and into cos t. And from here minus of x cos t is taken to left hand side, we get here plus of x cos t, and here is plus of y sin t is already present here, is equal to, here is a cos t into sin cube t, and minus of a cos cube t into sin t is taken to right hand side, we get here plus of a cos cube t into sin t. And from here we can also write here once again, this is x cos t plus of y into sin t, and from here we have to take common from here, this is a cos t into sin t, and the remaining is here a cos t into sin t, we have to take common, this gives sin square t, plus of here sin t is and a and cos t, we get here cos square t. And we know that from trigonometry sin square t plus cos square t is 1, so we have to write in here x cos t plus of y into sin t is equal to a cos t into sin t, and sin square t plus cos square t is, which is equal to 1, and further we can dividing once again, dividing both side by a cos t into sin t. So we have to get here, this is x upon, dividing a cos t into sin t, we get here x upon a sin t, and plus of y sin t divided by a cos t sin t, we get here y upon a cos t, and here is equal to 1. This is the required equation of the tangent. Thank you class, and thank you for watching.